Get this party started. Okay, cool. So last week we spent some time focusing on, excuse me, some rigid body dynamics. And of course we had the bowling lane example that really presented me with some big time problems. And I did some research on it because I refuse to lose. I'm a winner and I'm not going to let a computer beat me. So I found out the answer. And this is actually an answer that I'm really quite excited to learn about, because it brings into focus, I think, a major critical idea that everyone needs to be made aware of when working with rigid body dynamics. Okay, so let's rebuild the problem that we were all banging our heads against last week. Okay, so let's just run over into the Setup tab, and from our conversation that we had last week, let's define quickly the roles of each one of the elements in my little bowling lane here. Of course, the idea is that we're going to simulate an actual bowling moment, right? Where you bowl the ball, it knocks over the pin, and then of course the pin interacts with the ground itself, okay? So with that said, understanding the specification, the goal of all this, let's figure out real quickly the type of dynamic tag we need to place on each one of these elements, okay? So let's start with the lane itself. What kind of dynamic element is this guy going to be? Static, yeah, so it's going to be a static rigid body. I'm in item mode here. Let me turn off my snapping engine. Static rigid body, okay, because it's just going to receive information, receive dynamic movements, but it's really not going to move, nor is it going to be keyframed. So static is the one that we want to use. Now the bowling pin, how about this guy? What's this going to be? Active rigid body. So let's make it an active rigid body, and I'm going to start placing it where it needs to go. And I think you'll start to see here momentarily. Let me turn off the visibility of my lovely bowling ball, what the problem is. Okay, so as is, let me do this. I'm going to make my inactive message the same as my active message, excuse me. So let's see what we get just at the moment. Let's play the sim. Woo! A little bit of a problem, right? What happens immediately? Yeah, the ball falls through the bowling alley, okay? Now this is something that we can easily change, because really all we need to do, and the reason it is doing this is that the bottom polygon for our bowling pin here is resting exactly on top of the bowling alley itself, on the lane. So we're getting some collision when the simulation begins. If we simply just raise that bowling pin up just a millimeter or two, that should resolve our problem. Let's try it again. Okay, it keeps going, so let's raise it up even more. Still does it, so maybe, excuse me, raise it up some more. Oops, let's make sure. Let's change the collision shape for my bowling lane here. Right now it's at the multi-hole. Let's do mesh. Let's see if that influences the result that we get. My bowling pin's way up there. Yeah, and there it is. It works. However, if you look at it from the front, what is going on? It's floating, right? The bowling pin is a good, like, I don't know, a couple feet away from the top of the bowling alley. That's not what we want at all. So let's make some changes here. My bowling pin's way too high. With a new collision shape enabled, we should be able to lower this down to something, yeah, now it's much more reasonably placed inside of the scene. But it's still floating, and you can see the line right down there. It is still floating. That's not what we want. This was our frustration, because we couldn't figure out how to solve and get that pin to sit perfectly right on the bowling lane. Well, I did some research on this, and I figured it out. It's one of those things that I probably wouldn't have naturally made the connection to, but knowing it, it totally makes sense now, okay? This is an issue with the global dynamic solver in our scene. Right now, if we go over and select our solver, it should be at the bottom of our item list. Yep, oh, I already got it selected, awesome. If we go into the Advanced tab, what we need to change is the scene scale, okay? Right now, the dynamic engine is believing that our scene is actually much bigger than it actually is, okay? By reducing this number to something very, very small, we're going to more closely match the solver's interpretation of distance to the distances of the models inside of the scene itself. Okay, Right now, the default is a meter. Let's put this down to 10 centimeters. So basically a tenth. Okay, let's look at it again. Let's run our sim. Aha, so now it's much, much closer. If you look at the distance between the bottom of our pin and the ground plane, much, much closer. So we're getting there. Let's do it one more time. It's not actually that small. I tried to use real-world units because you can go online and very quickly figure out how big a bowling lane is supposed to be. And I tried to do everything to scale, but it's not the scale of the model. It's the scale of what the solver believes the model is at, right? Yeah, there's a sync issue here that needs to be adjusted. The solver is thinking that these objects are really, really big, but in actuality, they're very, very small, okay? If you think about it, when the solver thinks that our scale is really, really big, the distance that it's popping up, in reality, should be like a millimeter, right? But because it thinks our scene is gigantic, it's popping that bowling pin up pretty high, okay? So by reducing the scene's interpretation of scale down to something a little bit more manageable, that bowling pin is going to go. It's going to go lower and lower and lower until it's actually going to touch the ground.
Why does the solver put any space between it anyway?
The solver's looking at scale because it's trying to use its interpretation of all of the physical forces. We're working with the bullet time physics library, which is all physically based, right? So real world forces are influencing all of the active and kinematic rigid bodies inside of our scene. Those forces are being influenced by the distances that they are traveling, right? We're interpreting, or we're telling the solver how big our local world is, right? It has its default definition to how big it thinks the world is, but now we're localizing it just down to our model. I guess maybe the other way of thinking about this is the solver doesn't understand the local size of our objects. It's kind of this is a generic starting point with the idea that it needs to be adjusted to the local size of our objects.
I just think it's weird that 0 is 0.
The solver isn't thinking 0 is 0, right? Because our scenes can be any size that we want, right? I've done a pretty good job of trying to keep these in real world measurements, okay? The size of the bowling pin, I actually did some research on it. That's the actual size of a bowling pin. It's the actual size of a ball. There's a defined uniform diameter of a bowling ball, and I tried to match those as best as I could. The solver doesn't know that, right? The solver has a basic starting point, and then we need to go and adjust its understanding of scale to match our scene. Okay. So let's return to our solver, and let's do this. I did 10 centimeters. Let's do 1 centimeter. Let's see what we get now. Bloop. Now it's on there. Okay. Mission accomplished. Mission accomplished. That's a good little nugget. Now we can finish working with the ball. Let's get the ball going where it needs to go. Just going to bring it up. Did I make it an active rigid body? No, let's make it an active rigid body. And then how am I going to get this thing to move? Impulse, right? Impulse. So let's do this. Let's do impulse. I believe it is on the negative z. So we'll do negative 10 newtons. Let's see if that gets us where we need to go. Let's run the sim. Awesome. Okay, so mission kind of accomplished, right? What's my big time issue here? And I'll rerun the sim so you guys can see it from a different angle. Oops. What's my problem down here with the pin? It went back up. It's not supposed to do that, right? Yeah, it's one of those trick pins, yeah. Here's why, and I wasn't aware of this as well. As a modeler, our role, or the role of the center point, is very different than how the dynamic engine understands the role of the center point. The center point for me is placed, or when I created this model, I put the center point down at the base of the, excuse me, the base of the bowling pin, right? to make it very easy to duplicate and to position around on side of a plane, right? That was the idea. Well, in doing some research, I found out that the bullet time library interprets the center point of the item as the center of mass for that item. So we've placed the center of mass at the bottom of the pin. It now has a bunch of mass on top of it. It's like those little punching bags. So the base is filled with sand, and you punch it and it pops back up. That's what we're doing here, right? Because it's viewing the base as where it's the heaviest. Let's put it that way, okay? And it's getting knocked over and it's tipping back up, right? Luckily for us, however, the solution is really, really easy. We just need to center the center point to the bounding box of the item. Basically, putting the center point back in the center of the bowling pin is going to give us the result that we're after, okay? There's a great keyboard shortcut to do this, and I think I've shown this to you once before, but it's so cool that I'll show it to you again. If you go to the Edit pull-down menu, we have a command here called Center to Bounding Box, and then we get to determine where inside of our bounding box we want the center point to go, and I want it to be in the center of the bounding box. How would you describe the bounding box, the role of the bounding box? Anyone? Anyone?
It's like a box that outlines the maximum height and width.
Yeah, you got it. You got it. Now I've gone to my display tab on that mesh item, and you can see that we can visualize our bounding box here, and that's it. It's just a total volume. It's a box that represents the volume of this item itself. So what we're doing with this Edit Center to Bounding Box Center command is that we're asking the computer to look at that volume and to automatically put the center point in the center of the bounding box. Let's do it real fast, and you can see what it's going to look like. Boop. There it goes. Okay. Yeah.
Wouldn't the center of mass on the bowling pin be slightly lower than that?
Probably, yeah. If you really want to get the most accurate simulation, we have that neck where it tapers in the center. The center point, the center of mass, which should be a little bit lower. But I'm not going for super accuracy. I just want to kind of make it work. So I'd experiment with it, see if you get a different result, Leland. Okay, so now let's run the sim and see what we get. There it is. Rock and roll. Okay. Now there's a couple other things in here that we can probably establish. Maybe the weight of the bowling ball needs to be a little bit higher. So maybe we'll make this like a 12-pound bowling ball. Let's see how that changes the sim. Yeah, now the bowling ball is behaving much, much differently. Let's experiment around with the bowling pin, the weight of the pin. This is one thing that I didn't honestly think about. How heavy do you think a bowling pin is?
Google it.
7 pounds? We can Google it. Let's find out. That's actually a good question. All this information is highly accessible online. £3 6 ounces? Yeah, 3 pounds 6 ounces. Okay, we'll round up. We'll just call it 4 pounds. Play the sim now. Awesome. Cool. I'm liking that. Now the other thing, if you look carefully at the animation of our bowling pin, are we getting a realistic animation? No. Not really, no, right? Because let's examine the dynamic collision shape of our object. And right now it's set to multi-hull. Let's visualize what that looks like by returning to our solver and under the visualization tab. Let's do debug. Where's my hull? That's an interpretation. So that's the scene scale. Yeah, so there's the multi-hull stuff. Yeah, crazy, huh? Yeah. Okay. So one of the things that we could do for our bowling pin, maybe change its collision shape from multi-hull to mesh, and let's see if that gives us a more predictable result. Oop, let's turn off the visualization because that's really driving me insane. Oh, broke it even more. So maybe a multi-hull. Now where it penetrates through the back here, that's interesting to me. That may be an actual problem with the geometry. Let's go back to multi-hull. I think that's probably the best direction to go in. Awesome. Good times. Really good times. Hull and multi-hull. That's a really good question. Hull, let's turn on our visualizations here. They're very, very similar. So looks kind of like a lava lamp. Still kind of looks like a lava lamp. I want to say that multi-hull is specifically built for objects that has like recesses and indents, you know, a negative space and a positive space. Here's the best way to find out. And this is how I discovered the scene scale value, and it's important. I opened up the manual. How about the help pull down menu? Of course, we want to do online documentation. Actually, I'm not sure if I read the manual. I started looking at the online documentation for Moto and got a much better understanding of what this all looks like. So if you go to the help pull down menu, of course, we want to do online documentation. Actually, I'm not sure if local documentation is installed here. No, it is. Great. Fantastic. And under the simulation area, let's see, dynamic solver. This is where it talks about, I might have passed it already. Yeah, scene scale. Yep. So we were looking for dynamic items. It should be in here. Okay, collision shapes. So, oh, awesome. Hull isn't even on here. Fantastic. Or multi-hull isn't on here. Great job. Great job, Foundry. So the whole multi-hull does do all that. All right. No, not really, because if you looked at the debug visualization of the hull, it was very, very low polygonal, you know, in relationship. Okay, it didn't follow the curvature of the bowling pin exactly. It looked kind of like a lava lamp. Okay, now if I did mesh, then it would precisely match the curvature of the bowling pin. Hopefully you're beginning to understand that with dynamic simulations, or just simulations in general, it's a give and a take, right? You're not going to get, it's very, very difficult and costly to simulate our scene precisely. You know, I probably could go in and dial up a number of values and use different collision shapes and increase how many samples the solver is looking at in my scene. That's just going to take a longer time for the computer to simulate all this stuff. Okay. Real quick, let's just do some instancing of this bad boy. Let's do, oh, what am I going to do? Let's just do some instance cloning here. There we go. And let's duplicate that one. Oh, I didn't want to, sorry. I'm a dork. I just closed my project file on accident. I was trying to hit Control D and I hit Control W. And I closed it down. Awesome sauce. Well, I think you get the idea, right? Okay. So today what I wanted to spend our time talking about was I wanted to start talking about soft-bodied objects a little bit. Last week we spent all of our time talking about rigid bodies, objects that aren't going to bend and deform when things start striking into each other. But let's look at how soft body objects can be interpreted and influenced in our scene as well. It's pretty easy and it's very cool. Let me open up a new project file, and I encourage you to follow along if you'd like. I'm just going to use some unit primitives to demonstrate the technology, and then we'll look at some very specific use cases and increase our retention of this idea. So let's do this. I'm going to start off with the plane, and in component mode, I'm going to make that plane much bigger, and then no demonstration is complete without a little donut. I love me donuts. So good. All right, let's jump over into the Setup tab. Take a look, see what we got here. All right, so here's my donut. Okay, now I've got my plane down here. It's selected. I'll make it a static rigid body. But now on my donut, of course I could make it an active rigid body, but it's gonna solidify the walls of our donut, right? I want this to be kind of a rubbery donut. As if it's hitting the ground, it kind of behaves like a rubber ball. And so you'll see some deformation, and the polygons start to change their shape and deform based off their impact velocity on the ground. That's where soft-bodied rigid dynamics come in, or soft-bodied dynamics, excuse me. So you just got to click on it. Let's run the sim, see what we get. Boom. Awesome. Pretty cool, huh? All right, so yeah. So I just enabled it as a soft-bodied. I gave it the soft-bodied tag. Watch how it falls too. If you look at it from the profile, you can actually see it stretching and deforming based off the gravity in the scene. Okay, and it kind of turns into a big pile of goo. It is floating a little bit. If you turn on the grid, so how could we solve that? It is sliding too, right? Because it's got a friction. Both of these elements have friction values associated with them. So the first thing that I'm going to look at, let's look at the dynamic shape. For soft bodies objects, you don't get dynamic shapes. It's looking at the mesh for all of its collision information. Let's look at the plane down here and its dynamic shape. And it's at the plane, which is exactly what we want. Let's turn it to mesh and see what we get. Anything different? Nope, it's still kind of floating. So let's change our scene scale one more time. And I bet you anything, that's going to fix it. Oop. So maybe I made it too small. Let's make it 10 centimeters. There we go. Now, we're so very close. Still floating a little bit. Let's make it 5 centimeters. 1 centimeter, it just collapsed, right? Awesome, by the way. So the other thing that we can do, and I'm going to put this back up, I'm going to leave it at 1 centimeter because there's a couple other things that we can do in here to see if we can stop the little donut from breaking through my plane. The low-hanging fruit is just to add more polygons into the plane itself, subdivide it by hitting Shift D a couple times. This often fixes some problems. So Shift D. Let's see if that fixes my problem. Nope, still blinks out. Yeah, let's give that a try. Nope. Yeah, that's the next step, is the frequency. That frequency is kind of like a sample rate. Right now, if you look at it, let's do a couple different things. Let's put my scene scale back to 5 centimeters. That seemed to give us an okay result. And then that thing. Okay, now I'm in the solver at the top. This is kind of like the sample rate. This is how many times the solver engine is is firing off per, I can't remember if it's per frame or per cycle, or because there's a difference between, there's some differences in when it fires off. But increasing this number will give you a more accurate simulation. Let's put it to 240, see if that changes it. See how much longer it's taking for it to calculate? We're getting a much more accurate simulation now, but it is taking longer for the computer to process all of it. Let's put this back to a meter for the scene scale. Let's just see what we get. Yeah, it's really floating. At a centimeter, what do we get now? Yeah, there we go. Oh, and then it kind of breaks through. I wonder what is actually happening here. Let me run the sim, cache it to the timeline. That way we can step through the sim and see exactly what's going on. So on frame 46, however, it does land, not completely on it. I wonder if that's a center point issue. I wonder if I had the center point of one of these elements not set correctly. Why does it just blink away? Yeah, it totally just disappears. Awesome. It thinks that it's interesting to me. Wonder why. Okay. Oops, excuse me. Let's go back into our global solver. Put this back at 10 centimeters. That way we can at least play with this a little bit more and have some more fun. I'm also going to put my physics rate back to 120 just to make it a little bit easier to see what's going on. Bloomp. Awesome. I don't care so much that it's floating because I can figure that out later time and date. Okay. So how do we continue to influence our soft bodies objects? Well, let's go back into our donut here. And under its dynamic tab, it's basically these three values here. Those three are responsible for determining the, I don't know how you want to put this, the elasticity of our object, okay? And most importantly, probably shear. Let's look at these values. They all go from 0.01 to 1. So overdriving these things past 1.0 is not going to have a big effect. But let's put the shear down to something very, very small and see what type of result we get now. Yeah. Cool, right? The structure kind of collapses in on itself pretty quickly. Now, in addition, let's lower the structure value. See what we get. Yeah, it's collapsing in on itself even more. I've had the most success with shear and structure. Stiffness bend, it's supposed to establish the rigidity of our elasticity. Let's put this, let's put this to 1. See what we get. Something similar, but is it similar? Yeah. I don't do stiffness bend all that much. Structure and shear are really the ones that I kind of zero in on. Structure is supposed to try to keep the original structure of the shape. It's kind of a modifier. If you increase this value to 1, it's going to try to keep its original shape. Lowering that value is basically saying, hey, you can do whatever you want. You can deform this thing into whatever kind of piece you'd like. Let's put structure to 1, see what we get. Yeah, it's not as, it's still collapsing a little bit, but it's kind of wiggling, right? Okay, that was awesome. You see how I was running the sim and I made changes to the values and it updated live? That's pretty cool. I think this is the accuracy of the deformation. Increasing the number of clusters is going to increase the accuracy. Let's see, I think if I remember correctly, it also like doubles your render time. Pretty cool, huh? It's a lot of fun. All right, let's see what happens. I'm going to play with my little toy here for a second. See what happens when we tip it up almost 90 degrees. Awesome. You got it. It's pretty cool. It's a lot of fun. So we can do a lot of soft body dynamics as well. We're not limited to just doing, bowling pins and destruction type effects. Yeah.
So that, I'm assuming that's how like water. If you work.
No, this is not how water is done. Yeah, water requires a fluid simulation. If you want the best kind of example of water, let's see if the guys at RealFlow have anything. Okay. So RealFlow, my next limit, these guys and gals have the best fluid simulation software out there, and it's quite good. Let's see. Sometimes in these demo reels, they have like a behind-the-scenes look where you actually see the solvers. These, of course, are all the final finished effects. Let's see. Yeah, it's crazy what you can do with fluids. It's pretty neat. Yeah. And really what they're doing here is they're creating a dynamic particle simulation that's behaving like fluids. All the particles are clumping and moving and responding to the factors and the forces in the scene like fluids would. Okay? And then we render those, actually not too dissimilarly to the way Modo renders it. They have some awesome technology that really makes this, the best in the world. It's also the most expensive app in the world too. It's not cheap, and I believe the licensing structure is expensive as well. I think they used to have an academic price that wasn't too bad, but the real world prices was intense. Let's see. Let's just do a. Maybe it's on the RealFlow's website. I really haven't. Let's see if there's any sort of visuals in here real fast that will show you what specifically RealFlow is doing behind the scenes. Yeah, this is high-end stuff. I would say Moto is like medium-end stuff. It's right in the middle. The thing that a lot of these applications do, they try to be generalists applications, right? Moto's that way, Max, Maya to a certain degree, Cinema 4D definitely is. They try to be many different things, a full suite of tools. And then there are tools that are laser focused on one thing, right? Laser focused. RealFlow is laser focused on one thing, okay? Houdini, in my opinion, is laser focused on one thing, and that's all of their effects type stuff, including particles, dynamic simulations, and soft-bodied stuff. Houdini has some of the best dynamic simulation tools in the business. They're fantastic. Yeah.
This is a tad bit unrelated.
Awesome.
I just did that. Well, I did that experiment.
Go ahead.
Oh, I did that experiment with the human mesh. And it looks like the ending of Roger Rabbit. You know what I mean?
Yes.
Here, mine's computer number.
The dip.
Yeah, mine's computer number.
When I went to ILM, think of that. I went to ILM a couple of years ago, and I got a tour of it. And they actually had that character. At the end of Who Framed Roger Rabbit, the judge gets rolled over by his steamroller. You guys know that moment I'm talking about, right? It's an awesome moment. It's a great moment. Right, exactly. Christopher Lloyd does a great job acting in that moment. Well, the guys at ILM, they made the practical dummy of him all flattened out, and it was the weirdest thing. At ILM, they actually had that prop hanging on the wall. So there's like this flattened Christopher Lloyd in his costume on the wall, and it was awesome to see it, right? Because it was the actual prop they used in the film, but it was right next to the men's room. So I was going to the bathroom and I was like, what? It's the strangest thing on the face of the planet.
Pat,
Yes.
if you were to do water, what application would you use?
Real flow. So here's more real flow stuff. Maybe they'll show you some behind the scenes of what it does.
You don't have the money for real flow.
I would look into Houdini. I really would. Yeah.
So basically, in this program we're using, it's fair to use it for like Jello or something, or a trampoline.
I would for the soft-bodied stuff. Yeah. You certainly could. Yeah, you certainly could. Now the soft-body stuff actually takes on a new light because really wouldn't recommend using soft-body dynamics for what I've shown you. Okay. I wanted to show you the process of inserting the tag, but really the soft-body stuff, in my opinion, really comes or really serves well for like clothing. Okay. Because if you think about it, how clothing moves, that's a soft-bodied object, and we want those polygons to detect collision and to change its form based off of the collision information inside the scene. So let's take our example up a notch here, and let's do this. I'm going to make this undynamic, and let's reset everything. Just select it, then hold down the Shift key, remove dynamics. That's maybe a 901 thing, Arthur, so you might not have it. Oh, great, awesome, even better. Yeah. Okay, so now we're back. All right, this time let's change it ever so slightly. Okay, we have the plane, which is a static rigid body. My toroid, my donut is not anything at the moment. Let's also make it a static rigid body. But this time, what we're going to do, we're going to make a tablecloth. Okay, which is initially going to start off as just a simple plane. Okay, so I'm going to hold down Shift, add a new plane into the mix. Let's raise it up a little bit, and we'll raise it above the entire thing. And like we did earlier, I'm going to do Shift-D to subdivide it a couple times, because the quality of our cloth is entirely, and I mean entirely, dependent on how many polygons are infused on the actual mesh object itself. So I have a pretty high-resolution cube or plane here. Let's make it bigger. There we go. And now let's make this item a soft body. Okay. Let's run the sim, see what we get. Cool, huh? Yeah. Looks like a napkin. If it's one polygon, you want... All right, let me go back in time. I can do that. Yes, absolutely. Here we go. I'll make it bigger. This is going to be silly. So it kind of works. Yeah, it kind of works, but it still works. Okay. There was a question. I want to make sure the question gets answered. I didn't hear what the question was. So I think the question was, can you UV map this? Yes, absolutely. You can UV map, and you should UV map it. I believe this one's already UV'd. Yep, good. Good. It is currently only one-sided, okay? But however, that's something we can change, right? We can make it a two-sided polygon pretty easily with material.
So why does it like float down when it's on the soft body? You know what I mean?
Hold on 2 seconds, okay? Inside of our material properties, where is it? I so rarely do this. But there is double-sided. There we go. So it's in your material reference section. Now, unselected, it looks like it's got geometry on both sides, even though it doesn't. Okay, it's going to render that way too, which is pretty exciting. Okay, So
If you made it thicker, it would probably hold it up differently, right?
it absolutely will. Yeah, absolutely. Okay. So let me make sure I've still got this as a dynamic object. Soft body. Yep. Okay, cool. Let's see what it does now. Awesome.
So how much definition can Moto handle? How many times can you subdivide?
I don't know. Let's find out.
Well, I mean, at that point, doesn't it kind of, at a certain point, doesn't it?
So I got 16,000 polygons selected. Let's see what happens. Let's see what happens. I'm going to guess.
Just do it until Moto crashes.
And then it broke.
Reminds me of the movie Evolution. That's it.
At a certain point, would it be more hardware reliant than,
This is the give and take, right? This is the give and take inside of our system. For the donut, I'm going to change its collision shape to convex decomposition so we can see if we can get some simulation in that opening there.
Oh my god.
Yeah, there we go. Oh. And then, yeah, perfect, nailed it, render. Render that bad boy, I'm done. Let's call it a day, it's time to go home. So clearly, considering that Moto is moments from crashing here, this is not the direction we want to go in. A little too many polygons for my little iMac here. And I'm, awesome. I'm doing something that we would not normally do. I'm doing some dynamic simulations while I'm live streaming. My little CPU on my iMac here is just being taxed much differently than it normally would be.
The little CPU that could.
Yep, the little iMac that could, and it's crashed now, so Moto's no longer responding, so it's time just to take it out of its misery. We'll start a new one. So let's put this into production a little bit, because I've used this system a number of times, and it works really well for the most part. You guys probably have seen that little boat that I made, the HMS Victory boat. Well, at the top of each one of those, I've made a flag. Okay. Well, yeah. Think through my magician's box of tools and tricks. You know, that flag. I didn't sculpt that flag, right? That'd be a waste of my time. I set up a dynamic simulation, made it a soft body object, blew some wind on it to make it look like it was flapping in the wing, and then I froze the transformations on that soft bodied objects. It's now sculpture. Okay? So soft body dynamics can be used in a lot of different capacities. Let me show you how I did all that, because it's pretty cool. Clothing is a natural application of soft body dynamics. Now, one of the things that I've provided you this week is flagpole scene. Okay, you can find this in your D2L content, so please check this out. It is it's right there, flagpole scene. Okay, so if you want to play along, I would encourage you to do so. Oh, well, how about I make week 9 up? I'm sorry. Now it's up. Refresh your page and you should be good to go. It's just at the root. Here's what the project file looks like. It's very, very basic, okay? But let's look at how we can use the soft body dynamic system to create a flag flapping in the wind, okay? It's a great way to infuse a little bit more realism into our scene. So walk me through it here real fast. Walk me through it. What do I need to do? Let's go into the Setup tab, start getting all this stuff to work. Yeah, so flagpole is going to be static. Okay. What is the flag going to be? Yeah, soft-bodied object. Let's just run the sim as is and see what we get. Woo! Okay, awesome. Woo!
So you have, I mean, obviously you have the parent thing, you know.
No, and this is the next step. The cool thing about working with soft-bodied objects is that we can pin portions of it to other objects in the scene, okay? And we're really not pinning the flag to the pole. we're basically deactivating and reducing the influence of the soft body and rigid body solver dynamic system on the item itself. We're basically turning it off in certain areas and having the rest of it be affected. It's a trick. It absolutely is a trick. Let me go in. I'm going to select the flag itself. And in item mode, or after I select it, I'm going to immediately go into vertex selection mode. And I'm going to start selecting the verts right around the flagpole, the opening, the grommet, if you will. Okay? So I don't want the flag to fly away, right? I want to turn off the dynamic engine at those selected vertices. Now, what we need to ensure that we do is go back over into our Lists tab and just open up this weight map, because I always like to have it on just to ensure that the next step actually gets registered. What we need to do now is go back over into our dynamic tools and say make anchors. So those verts are going to be the anchors inside of our scene. To ensure that when I click make anchors, this weight map called goal is created. Now, let's check out the actual weight map itself, and you can see what it is. Where it's red, the soft body dynamic engine is not going to influence our flag, or it shouldn't. I'm going to deselect it, run the sim now. Yeah. It's a step in the right direction. Okay? Yeah. Step in the right direction here. So let's run it again. Let's see. I'm just going to do a quick inspection in here. Make sure. Awesome. All right. Let's see what we can do here. Let's go in. I'm going to start selecting some verts here. And this is the great thing about working with vertex maps, is that we can reduce their weight. I may have grabbed too many of them. Because it's not an item. This may be a difference between 801 and 901. So just select the vertices. Okay. Go into your flag. Go into vertex selection mode, and I just grabbed the verts that are right around here. And then with them selected, you have to hit make anchors. Now you want to do both openings at the exact same time, because the soft-bodied engine now is looking at that goal map. Let's just see how that affected everything. And it made it even worse, actually. So you're saying go in and add some weights in here as well. Yeah, we could try that.
Well, I mean, what I did on mine was like on a road, I selected the mesh, then I want to just like the other one, then I adjusted it. And then I had an anchor.
Okay.
It kind of, I was messing with it. There was a time when I didn't have the anchor in my item. It didn't work. And then when I did it again.
Well, let's give that a try. Let's give that a try. So you selected that like that?
Well,
Let's just do it. Let's do make anchor. Okay, now we have an anchor in here. I've never actually had an anchor show up, but let's run it.
you gotta adjust the weights.
Yeah. Okay. Okay, so let's give it a little bit of weight here. I think it's 6 to 1, half a dozen to another. I think we're doing the exact same thing, just in different ways. Let let me go back in. So this is a very, very different production pipeline than originally I went into. This is a suggestion by Randall. Let's see if the selection order makes an influence on that. Now it just pops off, okay? But that's not a bad thing, okay? Okay. Yeah, okay. Let's delete all this anchor jazz. Get it back to where we had it before. Okay, cool. Because this is, I've always been pretty successful with this. When I was prepping this before, just doing make anchors, it adds that goal in there. Now it's going to use the weight map on the goal to determine the influence of the rigid body system or the soft bodied system. Let's see if it works now. On the flag. And mine blows up too. I love it. This is such a fantastic example of why I hate teaching. I literally did this about a half a dozen times before class started, and I got the perfect result every single time. And then I come in here.
And it's just like, showtime, and
Yeah, exactly. Yeah, no, it totally just flops and hangs on the pole. Is that what you're getting in yours? Yeah, so, see? Okay, so with that said, here's actually something that all of us should get into the habit of doing when we run into problems like this. Because on my machine in my office, doing this production pipeline, the sequence gave me the result that I was after. This machine is not giving me that result. So that leads me to believe that there's something inside the configuration file on this installation of Modo that's causing it to not work, basically. So let's basically reset everything and see what we get. This happens often when the configuration file gets corrupted. Things don't work the way they're supposed to. Not everything. I always reset first, and if I still have the exact same problem, there's one more thing I can do that I hesitate to show you guys, because I hesitate to show you on these machines because you can very easily destroy our little lab computers here, because it requires going into the preferences folder, the Macintosh preferences folder, and you can break things in that area. But you guys are adults, so I'm going to assume you're not going to break stuff, so I'll show it to you. Okay, let's do this. We're back to setup. Let's make this let's make this a kinematic rigid body, just for giggles. I'm curious if that's going to have any influence on this. Let's go back into my flag. Start adding some anchors in here, some goals. No, at this point it's already a soft-bodied object. Yeah. See if I just play, blue, there it goes, awesome. Now let's make the anchors. Let's look at the goal map. And it didn't actually put the goal in. Okay. So I'll do it for him. There we go. Ah. Now it's going to crash on me.
We should have like, you know how they have like injuries on the job in the past 5 days? We should do that at Modo.
A little sign here that I can flip down things. How many times Modo's crashed? I'll be honest with you. I honestly believe that there is something in our installation of Modo that's broken. And I'm starting to think that maybe it has everything to do with how our computer services department has cloned each one of these machines. Because I've noticed that in this lab, I can't speak for the design lab, but I've noticed in this lab, that we are incredibly unstable. Even when doing simple modeling operations, things crash pretty consistently in here. And that's not the experience I'm having in my office or at home when working on this version of Modo. So that leads me to believe that something's out of whack.
It crashes pretty often.
Yeah, does it crash? So, okay, so that's even further proof that there's something in how computer services imaged and cloned all these machines that is, that's no bueno. Okay. Yeah, exactly. And on my laptop, I very rarely crash. And on my laptop, this example, using what I just did, worked perfectly. So something's going on. All right, here's the last thing that I'm going to do. Okay. And I really like the fact that Luxology has done this because it makes it very, very easy to get to your Modo configuration file. Now, this is a deviation from the Mac and the PC side. If you're a PC user, I know we have a couple of you guys in here, where you find your configuration file is very different than where our configuration file, or where our configuration file is, okay? So the locations are going to be different, and what they're called on a Mac and what it's called on a PC is going to be different. For us on the Mac, and I think you can do the same thing on a Windows machine. Rob, maybe you can help me out on this. So if you go to the System pull-down menu at the top of the screen, open Preferences folders. I believe on the PC you have to go into your configuration folder. But let's confirm that. So let's do the Mac first, since it's the easiest. These are all of your global application preferences across the entire Macintosh computer, which is why it's kind of dangerous to go in here, right? However, what we're looking for, see all this is com.microsoft, com.excel, Office Setup Assistant. These are all the preferences for, oops, I passed it, there we go. These are all the preferences and configuration files for all of the apps that are currently installed in this machine. And I found the com.luxology.modo. You can actually see that I have 3 different configuration files for Modo 701, 801, and 901, okay? In addition, there's that P list, okay? So for us on the Mac, if we delete basically everything that says com.luxology, we're going to reset Modo back to its factory defaults, okay? Let's move to the trash, and then I'm going to empty the trash so they're no longer referenced, okay? Now, it feels like we just completely destroyed Modo from working, but we didn't, because those 2 files, the P lists, are going to come back, okay? So watch what happens when I launch Modo. With Finder in the foreground here, we may see, yeah, see the Modo 901 guy just came back. Okay, so now we're working with a new configuration file. And let's see. Yeah, so it's a little bit confusing because if you do open user configs folder here in the PC or here in the Mac, for us on the Mac, it's not going to say anything. For you, Rob, do you have things to say .config in there?
I didn't even go in config, but right here.
I've actually always been really curious. Yeah, those are the ones that you can delete. I believe those are the ones. Those are your configuration files that you can delete.
It just went right to them.
Great, perfect. So let's see if that fixed our problem. Okay. What in the world was that? All right, let's see if that fixed our problem. Hopefully it did. Okay. Sure. So you just select, okay, so I'm on my flag, right? I'm going to select the 2 rings, okay? Then you hit make anchors, and now it's not even adding the weights in there. Let's see. I've been doing this in edges, though, and I'm pretty sure you're supposed to do this in, inverts.
Yeah, no, you can, on mine I was able to use the circle.
Yeah, but if I've learned one thing about demonstrating things on the computer, don't deviate from what you prepared, because that will always come back and bite you. And I know that, unfortunately, from experience. Okay. Make anchors. There's the goal. Ah, see, look. And now on my computer, it added the weights for me automatically. Thank you. Okay. Let's see what's going on here. Let's put our scene scale down to something small. Awesome. That's just working so well for me. Let's actually run the sim. It is technically doing what it's supposed to be doing. Yeah. However, let's do this. I'm gonna use Mr. Elliott's suggestion here. Okay, so I've deleted the goal map, in every sense the anchors between those two things, and let's try this. I have a memory of doing this a long time ago in a galaxy far, far away. Okay. Now let's add the anchors. Okay, that's what Mr. Elliott suggested. Let's see if that works. No, they still pop off. However, with that said, yeah, I was like, there's no weights on them right at the moment. So let's do that real fast. It shouldn't, because a polygon is made up of vertex components. Yeah, I have a memory of doing that at 1.2. Remember, like back in like 601, doing this example and having to put weights on both sides. But earlier, I kid you not, earlier when I was doing this, it was I did it the way I demonstrated in class, and it worked quite flawlessly.
No, it's not the mesh.
I don't think it's the mesh,
Mine
yeah.
works just fine.
His worked just fine. Tempted to go get my laptop, plug it in, just so you guys can see that I'm not going crazy. Which brings me back to the installation of Modo on these machines, because that seems to be the problem. On my laptop, it worked fine. Arthur and Rob are on their own local PC or laptops, and all these desktops are giving us issues. Yeah, that's not actually a bad thought.
My soft body wasn't working at all.
Yeah.
Every time I dropped that donut, I was pretty bummed because
Interesting.
it was still staying as a donut.
Interesting. Yeah, I'll tell you what, let's take a break. I'm going to restart my machine, and well, I guess I can't. Well, I'll restart, and then I'll have to start and stop the stream.
Can you restart when we leave, maybe?
Yeah, is anyone else getting the exact same, David, are you getting the exact same problem on yours? Can you restart your machine and see what it looks like? Yours is actually kind of working, kind of. Mine's totally not working. Let's put some wind in there, because that's the next step. Nope.
So you just pretty much push wind and base it some.
Yep. The arrow it represents the direction of the wind, and I crashed, of course.
Oh, that's so cool. Wait, how do I see my wind?
Okay. Or is yours not showing up a goal, Leland? Interesting. Here, I'll tell you what. Wow, why would I not make that? I'm not going to make the flagpole a rigid body. Just for giggles.
The way I did it is I selected all the vertices.
That's what I did.
Yep, I got the same thing.
No, not just the circle. Like,
Well, what other vertices?
So the one that around the.
Oh, okay.
That's how I did it.
You can add those in. That's no problem. Let's do that. See if that makes an impact. Make anchors. See, that time I didn't make. Oh, because I don't have the flag selected. That's why. Make anchors. There's the goal. Add the weight. Let's run the sim. There we go. That's what I'm after. Okay. Now, with that done, let's make the pole static rigid body. And then it goes crazy. So there's something with the pole. Let's make it, maybe it's a collision shape thing. Make it a kinematic rigid body. So kind of works, but it kind of doesn't work.
What was the pole at when it was working? It was active body?
It should no, it's not an active rigid body because then it would just fall, right? There's nothing that's keeping it where it is. Right now it's a kinematic rigid body. Let's do mesh for all of its. Oh, it probably needs to be convex decomposition for its collision shape. Nope, that actually makes it worse. And I'm crashing again. Ah.
So deleting those files did nothing.
Did nothing.
Wait, you made it a kinematic rigid body?
Or you can make it static too. It should be a static. You know, the benefit of making it kinematic is that you can now animate on top of that. All right, I'm going to try one more time here because we got positive results by making the flag, doing the flag stuff first. So I want to make that a soft body. Grab all those verts.
Oh, but those anchors. So after I would make the pole kinematic rigid body.
There we go.
I would have to tie the anchors to it.
I'm sorry, can you say that again?
I would have to tie it because whenever I move the pole,
Uh-huh.
the flag isn't going with it.
The flag isn't going with it. Interesting. Well, it kind of...
Staying with the anchors.
The flag is staying with the anchors. Okay. I don't know. Let me finish my train of thought here for a second, and then we'll go back into that. Okay. The last thing that I wanted to show you guys is you can add wind. Okay. Because without the wind, you can disable this, so you can get a before and after. So this is what it looks like right now. The flag just falls, and it stays. We're getting the illusion that it's pinning against those two brackets, but it is getting a lot of penetration through the pole. However, if we turn our wind on, so I've just added a wind force here. Let's enable it. I just clicked on the button that said wind. Okay. Okay, now the thing with wind, notice that it's got an arrow coming out the end. That's the direction of your wind. Okay? Yeah. Good time. Yeah. I've seen that happen a couple times too. So it's bag flag. It's bag. So we can also, let's bring the velocity down. This is the power of the wind. There we go. Sad flag. Now it does not matter where this wind is positioned in your scene. Okay, so don't think that, oh, I'm going to blow it up here. No, that's not how it works. Okay, it's a global wind force. Okay, and it's only going to go in a linear direction. So if imagine all the air that's coming out of your wind, it's just going to go in a straight line, linear. It does, yeah. So if you do like the strength, yeah. So let's do it. Let's tear off the flag here. It's moments from being ripped off. That's awesome. Let's do it. I want to break it. I want the flag to rip off. Yes. Oh, wait, no. No. Okay, good.
It just went straight to flat.
Yeah, exactly. So one other thing about the wind, because as we just kind of noted, it's only going to be in blowing in a single direction, okay?
Can you add like another little thing of wind?
Yes, absolutely. So check it out. So we have a couple other forces in here that we can establish, okay? So we have wind, which is a force, but we also have some other forces in here that are good to know about, specifically turbulence. When it comes to wind, maybe we want to add a little bit of randomness into our scenario here. Yeah, we're getting a little bit different effect, okay? So now the wind is no longer going in straight lines. They're kind of going like this, okay? Which is cool. As one might imagine, let's get rid of the turbulence. The other fun one's vortex, okay? Let's see, now vortex, let's do this. Let's lower the strength a little bit. Let's see. So by messing around with some of these parameters, you can get some interesting results. Let's change the angle of my vortex. Let's see what I get.
What if you move the vortex? Is that gonna?
Yeah, movement really is going to have a big influence. Oh, no, maybe it is. We're not getting as much spin as I was kind of hoping to get. There we go. That's a little bit more. Well, it's kind of sucking it in at the moment.
Another vortex and make it move like around or something.
To get what you're after, I believe what we need to do, let me just get rid of both my vortex and my force. Or my turbulence. Let's do this. Let's add in, is it radial? I think it's radial. Oops. Oh, wait, no, radial is different. Radial is going to suck things into it. Yeah, like a black hole. Which is why my flag is now going. See how it's always going to it? However, what if we can repel it by going like a negative 100? Kind of, yeah. Now it's repelling it. These forces are a whole lot of fun to play with. Now, one of the other cool things that we can do with these forces is that we can modulate their intensity with these fall-offs. Okay, there's a couple fall-offs in here that are kind of neat. Let's do the linear fall-off. Okay, and now if you look very carefully on my linear fall-off, we're getting an area of influence, right? We're out here at the end of the box where it's the widest. I believe that's 0%, and at the tip, that's 100% influence. So if I was to rotate this now and put this, and I may have those values reversed, so I apologize if I do. Now, I may have to get it actually on the flag too. Let's invert it. Oops.
So do these forces, do they affect active rigid body items or no?
That's a really good question. I really don't know off the top of my head. Now, why isn't my fall off working?
There's those, you know, we do like make
Is that all keyframeable? Well, the channels are keyframeable. Okay.
I think it's the same thing as anything
Yeah.
else. It would just work and capture whatever.
You got it. So probably if you wanted to like have it go like the wind, just keyframe the strength, right? Let me show you what I'm talking about. Let's get rid of that fall off because it's not working at the moment. I don't know why. So let's do this. I got my strength set at 360. This is the result that we get. Looking pretty good. Okay, cool. So now let's go in and start keyframing the strength. So maybe over the course of 30 frames. Yeah, let's give that a try. Mm-hmm.
Are you able to do an active rigid body thing to mesh that's already like animated, you know? For example, like if you were doing a walk cycle,
No.
be a lot of gigs or something, right? That was possible.
All right. So here's the graph editor for that change. And what I'm going to do here is that on my post behavior, let's oscillate it. So I'm going to take this one, I'm going to flatten it out down here at the bottom. So now 0, 0, and then it goes back up to 360. So now it's basically going like an oscillating fan. I don't know. So it's on. Oh, wait. I got to do it off the timeline. That's why. And off, and then on, off. Let's change my scene end to 1,000 frames. Let's play it from my timeline. Now it's on. Now it's off. Now it's on. Oops. Let's make my preview range much longer. So on, off, on, off. Yeah, pretty cool, huh?
What about that inherent velocity thing?
Inherent velocity thing, yeah, on the wind. So,
Drag it and it'll look like it's flowing?
I'm sorry, say again?
Is that where you can drag the flag and it'll look like it's flowing?
Yeah, absolutely. Right, yeah, because it's going to inherit the velocity of the objects that it's attached to. So if we were to get the pinning to work probably the way we could move the pole, and the flag's movement would be dependent on the pole itself, or would be influenced by the pole. Yeah. Yep. It's good times.
If you were to unimap all this, could you put it in like Unity and it would work, or would
No. Nope. No. Yeah. This is Moto specific magic. Yeah. Absolutely. Unfortunately, not. To get this into work in a game engine like that, you'll have to use their physics engine to generate this type of movement. I guess the only way to get it to export from Moto and import it into a game is to actually bake the transformations, bake the vertex movements into each frame, and then save that out as an animation clip. But it's not going to be a dynamic element inside of Unity. It's just going to be like any other animation that you import in. It's going to be predefined and pre-baked. You use their stuff. Yep. Yep. You got it. All right. Let's take a break. Okay? Let's take a break. Yes. Okay, so I want you guys to go ahead and finish the bowling lane exercise. Okay, do a render. Okay, I've shown you now how to resolve the problem that we were running into. So we should be able to finish that little exercise out and produce some good renders with it too. Okay, so if you look under the bowling lane drop box, I've given you all the directions for this bowling lane little project. So 12 bowling pins. Okay, 12 bowling pins. Bowling ball must strike the pins. Bowling ball and pins must sit on the lane. It's going to be a 5-second animation. Please do a full-blown render. Yes, sir.
Yeah, but usually the standard, amount of bowling pins is actually 10 of those. Where would the extra 2 be coming into?
My imagination. Yep.
Wait, so you actually, that's not a typo. You actually want 12.
Yeah, but I don't know. I mean, it's kind of.
Is this a thing? Is this a thing?
Where would the other 2 be placed then?
Figure it out! Oh my gosh! I want your animation to have 12. Thank you for reminding me that the assignment that I'm doing is not realistic.
Does it matter what positions they're in?
No. Be creative. They can be in a circle for all I care. Okay? 12 bowling pins. Yes, more than 12. Absolutely. These are always the minimum expectations. Minimum expectations. At least 12. At least 12. 12 bowling pins. Okay? Have fun with it. Have fun with it. Yes, sir.
How do you have center point to the center of the box?
I'm sorry, say that again?
You have the center point to the value box?
Yeah, so it's really easy. You can find that command under the Edit pull-down menu, right? Just make sure the item is selected. And see, here's a great example. Let me turn off my dimensions tool. Okay. There's the flag. You can see where its center point is way over there. So do Edit, center to bounding. Oh, make sure. Got to be in item mode for this. Edit, center to bounding box, and then center right there. And now that object center point is going to be way out over there. Let's see what happens when I run my simulation now. I'm curious. Changing the center point may have a pretty drastic effect on it all. Yeah, interesting. Interesting. All right, rock and roll. Okay, so let's chat for a second about some other things that we need to talk about. I mentioned at the beginning of class today that today is going to be a day full of little things. So we've talked about the soft body dynamics. We've talked about cloth a little bit. I wanted to spend some additional time today kind of laying the foundation for particles, because next week is going to be all about particles. And then we're going to end the day with a homework assignment that's going to be pretty fun that I know all of you guys will really enjoy, and it's going to be working with Mesh Fusion a little bit as well, because that's going to be a component of what you're going to be building over the next couple weeks, okay? So let's talk about particles a little bit. I'm a big fan of the replication system inside of Modo. And in every sense, the particle system relies heavily upon that replication system in order for us to generate a lot of little things at each one of the location of our little dots, okay? Now, I think you've seen me demonstrate this before, but I want to go into some of the nuts and bolts real fast and really start explaining how the replication system works as a unit, as a core, okay? Let's jump back over into Modo real fast. And as a reminder, I'm just going to create a new project file. Let's just talk and chat for a second about the differences between the different duplication engines inside of Modo. And of course, I think I'm just going to do this with a very simple little teapot. Oops. Geometry, unit primitives, and current mesh, teapot. There it is. Wonderful. Okay, looking pretty good. Now let's name this thing teapot so it's a little bit easier to see. Teapot. All right, rock and roll. Okay, so of course we have basically 4 levels of duplication inside of Modo. Let's talk about the lowest level of duplication. What would be that low level of duplication? Clone, but what are we cloning? Polygon. So a component level duplication. Often that takes the look of duplicating polygons. So if I'm in my polygonal selection set, I can duplicate all or portions of this teapot just by selecting those polygons. Whoop, got them. Okay. And then over in our duplication tab, our clone tool is going to give us exactly what we think it's going to get, right? If you look very carefully, over in our item list, we still just have a single grand container in which all of these discontiguous teapots are living within, right? This is component level duplication. It's the most simple and the lowest, most unintelligent level of duplication that we have inside of our system, right? Because the computer is no longer interpreting and understanding each individual clone. Through its eyes, it's all just one mesh item, okay? If we take that a step up, what's the next level up inside of our duplication hierarchy, if you will? Even before we get to instances. Well, I guess, huh? Nope. Don't think about tools. Don't think about tools. Copy and paste what, though? If the lowest level was components, items, so the next level up would be the item level duplication, right? So I guess you can say item level duplication and instance level duplication are probably of equal importance, equal weight inside of the scheme. But now we're no longer duplicating the components of an item, we're duplicating everything on that item, okay? Notice that when I'm in item mode, all of my duplication tools over here turn that same purpley blue that we're used to seeing in the mesh item indicator icon over in my item list. And now if I was to do the clone, you can see what we get, okay? We get almost the exact same result, but each item is encapsulated individually, and we're getting individual items over inside of our item list as well, okay? Pretty unintelligent, though. What we get is the same amount of geometry. We get individual control over each one of our teapots, which is nice, and that's a beautiful thing. But how is it different from working with instances? You got it. So the geometry is referenced in an instance, right? On the instance copy, the geometry is always looking back to its root, its primary, its master, if you will, and any change that's made on the master is going to be ripple and cascaded throughout all of the instanced items inside the network. Let me show you what I'm talking about. Worked really good for those bricks, right? Yeah, it really did. No, and I'm glad that you said that, okay? So in order to make an instance clone, of course, we're going to hold down the Option key, and all of our cloning tools turn pink. And instance clone, we're going to do the exact same thing that we did before, okay? But now they're all pink inside of the scene. The great thing about working with instances is they're still items, right? So they get that same item level edit ability that we do with the traditional mesh items. We can go in, we can move, rotate, and scale each one of these items. We can animate each instance, okay? However, we can't change the geometric mesh of the instance because it's being referenced back to the original, back to this guy, okay? Any change that's made on the original is going to ripple update throughout the entire instance network. So if I do something like that, you can see what happens to the geometry of all of its partners. Any new element that I put on the master mesh item is going to be adopted immediately throughout all the instances. Yeah. Everything should go along for the ride. Should go along for the ride. Everything. Yep. Yeah. For example, let's just. Okay, so if I go over to my render environment now, yeah, any change that I make on one is immediately made to the rest in the mix, okay, which is pretty cool. However, I can't change each individual instance, though. It doesn't allow me to do that. They are true copies of this bad boy right here, okay? Now I can make global item level changes for an instance, okay? So I can go in and select this guy, and maybe I can right click on it, and down here at the bottom, this is actually kind of cool. You can create an item mask, okay? And now check it out. So I can, on an item level, affect the color of this thing, but I can't go in and individually change polygons, right, like I was doing over here. An instance is always an item, so we're forced to work at that item level transformation and deformation and rendering kind of level of ideas, okay?
So if you have that item mask on and you go back to the original and start changing polygons, it still changes.
Okay, so there we go. I've made changes to the original. Interesting, huh? Yeah. Shading and working with, excuse me, with instances can be a little bit tricky, because you really have to ask yourself, what are you filtering with that material group? This is getting into some advanced material now, so I apologize. And really, in my mind, whenever we create a material group, we're establishing a filter. We're telling a very specific component or an item or everything in our scene to adopt the parameters of the material that's inside that group. And you can even start to define that pretty quickly. You can see how what we established was a polygonal material tag, okay? You can even do selection sets, and we have things called parts too, which is kind of fun. And then this is the actual tag itself, okay? Now right now, any polygon that has a material tag of yellow is going to get the contents of that folder, right? Because the item level is set to all, but I can go in and say, hey, only maybe just do teapot. Well, these are instances, so it's still going to be kind of funky because it's looking back. Yeah. Yep, there it is. Apply a subgroup. I think that's what you need to have on in order to. Oh, but it went off on that one too. No, let's. Yeah, instances is weird. Let's see if there's a way I can get it to only show up on these and leave this one green. So there's teapot 2. It goes off. I do teapot 3. Now that one's got it, and this one doesn't have it. Yeah. So these groups, these folders are filtered by this thing first, and then all these other tags. It goes kind of vertically down. If it's on all, then anything, yeah, that's cool. Anything that gets that material tag is going to adopt those parameters. However, let's just check this out real fast. Why does this thing? Anyway, it's not what I wanted to talk about, but I think you see the idea, right? Okay. So instances, very cool. A lot of folks forget the idea that you can animate instances. They're still an item, and Modo has an item-based animation system. So these are still players inside of our world as well. Okay. There's one more duplication level, if you will, inside of Modo, and they're called replicators, and they're pretty fantastic. Now, replicators are very, very different from other duplication systems, okay? The item level duplication system will give you an encapsulated item that you can edit, right? We just saw that. We can move it, rotate and scale it. We can animate those items. They're still a first-class citizen in my mind of the animation and rendering engine, right? Oftentimes, however, we don't need to animate the duplicated object itself. We want something else to animate it, like a particle system, okay? You'll see this next week that we're going to create these wonderful particle systems. We're going to basically spew out a whole bunch of verts into our scenes, have them be affected by gravity. I want the movement of those vertices to establish the movement of maybe a teapot, okay? So something else, another item is going to be moving, and we just need to basically duplicate an object on top of that vert. thus enter replicators. Replicators are a vertex-based duplication engine. They're pretty fantastic, and they're incredibly, and I mean incredibly powerful inside of Modo. In my opinion, it's one of the reasons to jump into the Modo ecosystem. It's pretty cool. So this is what we need to do. We need to have a prototype. In our case, that's the object that's going to be duplicated, which is going to be the teapot. Then the next thing we have to have is the point cloud, which establishes all of the verts. Are you guys into this? Because I get the sense that maybe you're not into this. Should we just jump into the homework? Save this for next week? Yes, no? What would you like to do? Okay. All right, so we'll just jump into the homework. Because this is, I can see already that you guys are like, don't care about this so much. Okay. We'll save this for next week then. All right. Our homework this week, you're going to make a rocket ship. Okay. It's going to be pretty fun. It's actually going to be a really fun project. Let me show you what you're going to be using and how to use the Mesh Fusion system. Because I want you guys to get some experience with Mesh Fusion. It's one of those things that if you were taking GCOM 402 this semester, you'd get access to Mesh Fusion, but you guys have already taken GCOM 402, or you should have already taken GCOM 402. Okay? So you're not going to get that same level of love. And it's such an important idea and framework going forward that I want to talk about it in all of my classes this semester, because it's something that everyone needs to know. So if you cruise over to your desktop, I've given you guys some assets. It's under the, so here's the asset that you find on D2L. If you open it up, you get two project files. I've given you what my rocket ship looked like at the end, and then of course the start file, which has a whole basic series of building blocks associated with it, okay? So when working with Mesh Fusion, it is an interactive Boolean operation, okay? It's an interactive Boolean system that's item-based, so you're no longer working at the component level, although you can, okay? Let me show you how it works. It's pretty fantastic. A couple requirements, though, for the Mesh Fusion system to work correctly. The objects, the source objects of your entire network, the source objects of your Booleans, they absolutely need to be Pixar subdivision surfaces. Can anyone tell me real quickly the differences between a Modo subdivision surface and a Pixar subdivision surface? Bingo, and that's the great visual indicator. Let me just go in, and I'm in a new project file right now. I want to add a sphere into the system, okay? Now, if you look very, very carefully, this is a subdivided sphere, right? The rollover, I've zoomed in, so it's a little bit difficult to see, but the rollover highlight color for the polygon is kind of that pink hue, right? If you see a pink hue on your rollover color, that is a Modo subdivision surface. That's the algorithm that the guys down at the Foundry developed internally. It's quite good, it really is. However, it's not the best one on the planet. The best one is the Pixar subdivision surface algorithm. So we have two different algorithms that we get to work with. Let me hit the tab key and unsubdivide my sphere, and you can see its basic parameters, its basic polygonal cage. What's the keyboard shortcuts to get us in and out of the Modo subdivision surface? The Modo one. Tab. So tab is just how we get in and out of the Modo subdivision surface algorithm. To get into the Pixar subdivision surface algorithm, it's Shift tab. Now immediately you can see that the rollover color for the rollover highlight color has gone to green. So it's the only visual representation that we get inside the computer that tells us that we are working with a Pixar subdivision surface. Okay, so you have to look for it. Okay, it's not going to tell you in other places. This is the only thing. Okay. The Pixar subdivision surface algorithm is proprietary technology that belongs to Pixar. Okay? When Modo was created 10 or so years ago, they did not want to spend the money on the licensing fee, so they created their own. Since now Pixar has open sourced it. They think it's so awesome, and it is, that they said, we're going to give our technology away for free, and everyone can begin to use it inside their apps.
Is this the thing that when you were doing the tutorial, the lithology people told you it wasn't really Pixar or something else?
Yeah, and actually I need to back up because it's not Pixar subdivision surfaces. There are Catmull-Clark subdivision surfaces according to the documentation. Yeah. Yes, and I had to redo a number of videos because it kept saying, because originally when they released this technology in 701, they called it Pixar sub-Ds, right? And even they said Pixar sub-Ds all over the place. And then, or that was in 801, excuse me. And then when I did all the 901 videos for them, I kept saying Pixar subdivision surfaces, and they very not politely came back and said, you have to redo about half the videos because they're no longer Pixar subdivision surfaces, they're Catmull-Clark subdivision surfaces, and that was not a good day for me. Catmull, and I can show you where we can go. Catmull. Catmull, named after Ed Catmull, okay, the granddaddy of the computer graphics industry. He really kind of created everything, okay? He's the president of Pixar and, you know, the beginning of our world in the 3D computer graphics, okay? Yeah.
Could you just mute out every time you said it and then put in
Not really. Okay, who's watching the Star Wars trailer? I know the music. Who's watching it? It's next door. Awesome. Yeah! I love it. Love it. Love it. Love it. See, they probably heard us listening to it earlier. Now we get to listen to them listening to it now, which is awesome. Okay. Yeah. Yeah, I think it's awesome. So fantastic. So there are a lot of advantages of using the Catmull-Clark subdivision surfaces. One of those advantages is that we now get to enter into so distracting. So distracting.
It's just being a bit more epic with the background.
It is, right? I think everyone needs to have background music. One of the benefits of working with Catmull-Clark is that we now get to play inside of the Mesh Fusion world, and it's awesome. It's a rule. You have to work with Catmull-Clarks, okay? Let me show you how it works. I think I've shown this to you once, but I'm going to show it to you one more time because I want you to really use this system for your rocket ship. The homework is supposed to be kind of a fun one. You're just building with Legos this week, okay? All right. So you can find all of the Mesh Fusion tools. It's kind of hidden in the modeling layout. They're down here at the bottom. You get your own tab called Fusion, okay? And there's a lot of tools in here. But what we're going to do, or what we need to have inside of our system before we can really start working, is that we need to have two different items, okay? Two different items. I have one. I have a sphere. And under the Fusion Models category there, that section, this thing, this is a preset library, okay, of a whole bunch of shapes that the guys down at the Foundry have created for us. They're all ready to go, so they're already Catmull-Clark subdivision surfaces, and you can see that they're a whole series of really awesome shapes, okay? Cubic geometry, okay? Cubic geometry. All right, so let's do this. I think I'm just going to do, I don't know, let's do this cap, this cone thing here. So double click on it, it'll insert it into the scene, and now we need to do some work. Now, I would recommend the best case here, the best use of all this stuff is to work at item level. Don't work at the component level. It's going to feel uncomfortable moving these polygons around, modeling basically at item level, but that is the playground of Mesh Fusion. It's an item level interactive Boolean system, okay? So at item level, I'm going to make my cone here much smaller, and I'm going to move it up, okay? And let's do this. I'm going to flip it over 180 degrees. I'm going to make an opening in the top of my sphere. If you looked at your bowling ball for the bowling alley thing, I use Mesh Fusion for that because it was like a 2-second thing. Yes, why? Let's do that. It's all Rob's fault today. There we go. Death Star, okay? Beginning of the Death Star. Okay, all right. Now I have to make it a Death Star. Let's see, it's more, yeah, let's do that. Something, there we go. All right. Oops, I'm still axis-centered origin. All right. It's all live, so we can make adjustments to it as we fly. Okay, so we just have to have two separate items inside of our scene. Now, this next step, or in addition, you also have to think about how you're going to be using these two different items. I want to subtract the small sphere from the big sphere, okay? You now have to pay attention to the selection order, okay? Just don't click on things. Pay real close attention to what you click on and the order that you click on things. I'm going to click on this one, hold down the Shift key, and grab the small one second, okay? Now we're ready to rock and roll and physically create the new fusion item inside of our scenes. We'll do new fusion, and you're going to get this thing, okay? Of course, name it Death Star. We're just going to focus exclusively on the 3D tree fusion. The schematic fusion type is pretty advanced. As you can imagine, that's going to allow us to make these live booleans nodally. We can create small little kind of programs, sub-booleans that interact with other sub-booleans that all feed into something that's way more crazy advanced.
If you schematic fusion, do they all have to be cubic geometry, or you can make your own polygon model?
You can make your own, but they're not polygons, right? Because they have to be Catmull-Clark subdivision surfaces. Yeah, absolutely. You're more than welcome and encouraged to do your own. The rocket ship, a majority of that I did on my own. They're not cubic geometry pieces, okay? So you can do it, but the end result has to be a Catmull-Clark subdivision surface. Okay. So you pick the type of fusion item you're going to make. We're going to make 3D trees. And now we have to focus on what type of Boolean operation we want to initially fire off. So we have union, which is going to combine both the items, subtract others from the first selected. And this is why I wanted you to pay attention to what you selected, okay? And then we want to subtract first from others, which isn't what we want, right? We selected the big guy first, and the intersection is going to show us the parts where they collide, okay? So we want to subtract others from first selected. We'll click off. It's going to take a second for it to evaluate. There's a whole bunch of scripts that fire off in the background, okay? And now we can start working, okay? Mine looks kind of odd at the moment, but that's okay, because we can go over and we can do Fusion View settings. There we go. I'm also going to turn off my grid and my work plane, okay? All right. So the Fusion View settings here are important to look at to get that everything's shaded correctly. In addition, source mesh visibility, you can turn that on and off so that you can see the product of your live Boolean, okay? I'm going to turn off my wireframes just so we can get a look at it. Okay. I wouldn't for a character model. I really wouldn't. This mesh fusion, in my opinion, is really laser focused on hard surface objects. Yeah. Well, I take that back. You probably could do some character work, but it's not going to be. You're going to want to go back in and retopologize it into something of lower resolution, because if you probably already saw that's the weight that you're going to get. Okay, you're going to get a bunch. Yeah, and they're all going to be triangles too. Okay. Maybe, depending on your source mesh. Okay. If your source mesh has UVs already established, when you start inserting them into the Boolean system, then yes, your UVs will be prepared. Okay. I'm saying that because I've had success. I should put success in finger quotes. With it automatically creating UVs for me, okay?
So you're kind of rolling dice.
It's hit or miss, it really is. However, it is getting much better. Every time they do a service pack, the mesh fusion is getting much stronger in its ability to make UVs automatically for you, okay? All right, let's chat for a second about what has just happened. Of course, you can see the 3D tree just chilling over here. We'll come back to this in a minute. But of course, the operation over here is really where it gets exciting. Mesh fusion is awesome because they are live Booleans that take advantage of that awesome open subdivision Catmull-Clark engine that we're working within. Let me turn my source meshes back on and continue to mess around with them. Check this action out, right? Turn my wireframes back on so you can see it. So I can grab this guy and I can start changing its location. I can push it in more. You know, I can make it bigger or smaller. I can rotate it. It's pretty great. I mean, I won't lie. It's pretty fantastic. Try modeling that, by the way. That's not an easy thing to model, within a couple seconds, all right? They're pretty fantastic. They're pretty fantastic. Let's do one more. Let's add in another element into the scene, and this is where your fusion tree comes into play a little bit. Now, I've clicked on the root of my fusion tree, and you can actually move this thing around, because right now it's kind of in my Death Star. There we go. Because this is actually more than just a visualization of how the Boolean operators work. It's actually a tool. It's an interactive tool. It allows us to very quickly add new elements in to this entire fusion operator. Okay? Let me show you what I'm talking about. The tree starts from over here. These are all the source mesh items, and you can see that I'm just working with 2 spheres, basically. So these are all the source meshes. The next level in, these are all the Boolean operators, okay? There's 3 of them. The green one is union, the blue one is intersection, and the bottom one is subtraction. So if you think about it, the original one is always going to be placed on the union node, and then whatever is associated with that red arm is going to be subtracted from the original, okay? The scion dot, this is the branch operator. You can actually have multiple branches at the exact same time. Talk about that in the future. And then this is just the root node of the fusion item itself.
So the middle blue dot, is that the add thing?
This is intersection.
Oh, that's
This is intersection. So this is union. That's add, subtract, and then difference, basically. Okay. One other thing to note, okay, that when you're working with mesh fusion, what you get is a new item inside of your interface. You can see it down there at the bottom. That's the fusion item. This is the magic. This is where all of this fusion information is stored on that item. I'm sorry, the Death Star, down here at the bottom. Death Star, that guy. The Q-patch sphere and sphere, those are the source items for the fusion system. The geometry, the source geometry. This is something that we need to manage, this fusion item. It's a player. Specifically, if you select it, this is where, we'll come back to this in a minute, but right now, we're only seeing a preview of what the final finished product's going to look like, okay? It's in draft mode. If I do airtight final and airtight final with parts, then it's going to completely redo the math, clean up all the geometry, and get it ready for export, okay? We're not quite at that point yet. We'll come back and we'll export this here in a second, but I just wanted to introduce this idea that this is actually a player inside of our system.
Does Maya have this technology, or is it?
Nope. This is proprietary. This is a reason to jump into Modo. Okay. This is pretty great stuff, actually. Okay. Let's add a new element into the mix here. I'm going to go back to my cubic preset library, and let's put this cone back in here. Okay. And this is how awesome the system is, right? And let's make it even a little bit smaller. Oops. Me too. It's pretty great. It's a lot of fun. Okay, so now I have a new piece that I want to maybe add or subtract away from my Death Star. Okay, I mentioned earlier that the tree is a participant inside of our world. It's not just a visualization, it's a tool. It's a drag and drop tool. This is kind of cool. So check it out. So I got the item selected down over here. I can left click and drag it onto the subtraction node, and bloop. Now it's been subtracted. Okay? Just drag and drop. That's all you have to do. Okay? Just drag and drop. You can even select it here. Now I don't have my source visibility on, but you can see that its element has been selected as well. So it's a selection system as well, which is neat. So now I can go in, make changes, and life is good.
Will it always make all polygons triangles for you?
Yes.
So pretty much just you remap it and throw it in the game.
No. You want quad? This is. I mean, this is an insane amount of geometry for a game engine to handle.
So you wouldn't use this for a game engine?
This wouldn't be the final form of this model. I would retopologize it, okay? If you're trying to get this out of Modo and into a game engine, I'm going to have to go back in and reduce the polygonal load of this object because it is way, 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 way too heavy for a game engine. Say again? Bake it? No, I'd have to it's called retopologizing, okay? Well, I would probably look at, there's a couple different, I don't want to talk about retopology today. That's a 3-hour conversation in itself, okay? But there are some really great tools inside of Modo that will allow us to very quickly reconstitute this model at a lower polygonal load. Let's end it at that, okay? We can talk about that because actually retopologizing is something that we should look at. But let's just focus on the fun stuff today because retopologizing is very technical and very boring. They're after me. They want to arrest me for the awesomeness of mesh fusion. Okay. One other thing that I want to show you guys, and this is actually kind of cool. If you mouse over, oops, there we go. Of course, now it's not doing it. Maybe the other one will be a little bit easier to see. There we go. Okay, see how right there I get a light blue little preview ring? This is called a strip. A new strip is going to be created at the location of a Boolean operation, okay? And we get to control that strip, okay? It's pretty cool. If you look down here at the bottom inside of your HUD, you have a couple different parameters that you can play around with. So strip width. We'll increase that and decrease it. Okay, it's pretty rad. Profile is going to kind of tighten it up a little bit, kind of pull it all in towards the center, or flatten it out entirely. Okay? And then there's smoothing. Then we can basically smooth, the inside and then the outside. Okay, so we get to control the smoothing of both sides of the strip. Okay, yes.
Is this live? Is this like keyframeable?
Yeah. Mm-hmm. Yeah, absolutely. These are all keyframeable elements too. Yeah, it's pretty crazy. Now the reason I'm not getting that strip on this back one, okay? So here's what we have to do. We have to go in and we have to update all the strip items from time to time. That button right there. Let's just do it real fast. Let's update the strip items. And now, now I got access to that one. So if you don't see a strip, just update it. Now, at times, it's not magical. Okay? As that strip gets closer and closer and closer to the pole of my sphere, we start to get some errors in the topology. So it is both awesome, but we have to understand what the technology is doing, okay? It's trying to automatically triangulate and rebuild the geometry on the fly for us. Maybe a simple edit to the source mesh will give me the result that I'm after. Yeah. Oops, please don't crash. It's going to crash on me. It's only a matter of time. It's a pretty neat system. It's actually very cool. And there's one more thing I want to show you guys before I have you guys start working on your rocket ship, okay? Even though we're working at the item level for all these Booleans, that doesn't mean that we can't work at the component level to customize those shapes, okay? These presets are just a starting point. It's not necessarily the shapes that we have to use at the end of the day. We can also utilize the duplication engine at the component level to create, repeating pieces around our mesh. And I wish this wasn't hanging at the moment. It's driving me crazy. There we go. Oh, it's live. So the Modo gods have smiled upon me, and they have not had the computer crash. They rewarded my patience. Okay. Let's do one more thing here, and I'll do it. Let's do this. Let's go back into my cubic library. I'm going to grab a little hockey puck here. This little hockey puck is really infinitely useful. I've used this a number of times. And what I'm going to do, I want to make it a lot smaller. I'm also going to do this. I'm going to flip it over. Let's move it into position. Okay. And yeah, let's squeeze it down this way some. Oops. There we go. Okay. That'll do. All right. So check this action out. This is actually kind of cool. I want to subtract this little hockey puck from my entire system here. So I'll just drag it on top of the red dot. It'll subtract it. Awesome.
Oh, it doesn't even have to be a fusion thing? It can be just
I used one of the cubics, yeah, for the presets, yeah. Yeah, so there it is. Pretty cool. I mean, try modeling that. That's actually something that's not easy to model in a sphere. So that's fantastic. All right, but here's the cool thing. All right, so there's source meshes. Now, this is an item level duplications, item level Boolean system, okay? So it's looking at the total contents of my hockey puck item to get that little inset that I created in my final fusion item itself, right? Well, what if we went in, changed my action center to origin, and then duplicate it? Yeah, did a radial array. Let's just do 4 of these around the Y. Okay, and you can see pretty quickly that the fusion, here we go. Awesome. You can see that the fusion system has incorporated those duplicates as well. Now this guy over here, that's a much larger problem that we have to manage. I'd probably just go in and let's turn our source mesh visibility back on. Go grab my hockey puck guy. There we go. And I just delete that one. There we go. Pretty cool, huh? So we can still work at the component level if we want. Not everything has to be done at the item level, but I would highly recommend that a lot of things happen at the item level, okay? It really does make life a little bit easier, okay? All right, there's one more thing I want to show you, okay? And this is actually pretty neat. And let's do this. Let me find a good use scenario here. Actually, let's just go to the rocket ship and start playing with the rocket ship, because I think I have most things already started to dialed up for my rocket ship. Okay, so if you look at the parts and pieces that I've given you for the rocket ship, almost all of these are custom pieces. So they're custom subdivision surfaces using Captain Clark, and we can start adding these together meaningfully to create our cool little rocket ship. Now this is just the beginning. I want you guys to play with this. You don't necessarily have to do what I've done. Use these pieces as building blocks for your own rocket ships. But I want to show you something that's pretty neat and incredibly powerful. I want to have maybe some little thrusters down here at the bottom, okay, down over here. So let me open up my cubic preset library, and I think what I'm going to initially use here, let's do this tube, okay, because I want to make a thruster down here at the bottom, okay. So there's the thruster. Let's make this thing much, much smaller. It's a little bit too small for me. Let's move it into position here. Awesome. Okay. Now what I'm going to try to do here is I'm going to angle it out just a bit. Give it a cool shape. It's a good question, right? It's a good question. It kind of redefines the modeling process. All right. It's a little boring for me, though. I'm not liking this shape much at all, actually. I think it needs a little something, something. Let's do this. And I'm going to rotate it, too. I really want it to be tipped out. I think what's really kind of driving me crazy right now, yeah, what's driving me crazy is that I really would like it to have a taper. I want it to be kind of big at the bottom and then taper up towards the top. So we can go back into component mode now if we wanted to. Yeah, it's the front. Is it the front? Yeah, cool. And let me just use a fall off. So down here, it's not going to be affected. There we go. And up at the top of the pyramid, it's 100% going to be affected. Oops. Clicked on the wrong spot accidentally. Let's do that again. Okay. What is going on? Select it first, and then we'll throw the fall off in there. Awesome. Okay, and now I'm going to change my action center to selection so that the scale operation fires off along that guy. And let's see, I think I want the red one. Yeah. Now I'm getting that lovely tapering. Cool. Okay. Better. I'm liking it. Let's get rid of the fall off. And now we can start the Boolean operation. Okay. So let's do this. I want to grab my fuselage and my wings. It's a new fusion item, and we're going to do a union. Awesome. Yeah, I just combined the wings and the fuselage. Okay. Let's turn a lot of this other stuff off.
Does that affect your hierarchy at all?
Hold on 2 seconds. Okay. So now I have things starting to flow in. However, I want to be able to control this engine independently from the rest. Okay, I want to hook it in to my system here, but I want to be able to control all of its local edits separately on its own branch. Okay, because I want to be able to slice some stuff in here, and I want to basically cut off the end of my rocket booster, but not cut off the end of the actual rocket ship itself. Okay. Let me illustrate what I'm talking about here, okay? Let's do this. So let me go back into my cubic geometry, and I'm going to snag, which box am I going to use? We'll do this one. I clicked off it, sorry. There we go. Okay, so this is the box I'm going to use. I'm going to scale it down some. This is going to be like a cutter for me, okay? So I basically want to come in and do this for my rocket booster, okay? I want to cut off the end of it and create a really fun flange down here at the bottom, okay? But in order to get the angle that I'm after, okay, see how my cutter piece goes into the fuselage of my rocket? I don't want this piece to influence my rocket ship. I only want this piece to influence this like sub-booster thing, okay? So we're going to make a new branch. Make this a little bit fatter too. Okay, awesome sauce. Coolio. All right, so it's really easy to do this, okay? Of course, we're going to go into item mode, and we're initially going to start with the outside rocket. And if you, oops, I got to turn source mesh on. Now with source mesh on, you can drag it on top of it. And oh, they have changed something in 901. Or in this version of 901 that you used to get a popover menu here. So let's do this. Nope. Hold on a second. There used to be, when you drag it on top of it, let's try this. Yeah, now the match. I don't want drop actions, and now it's defaulting to drop actions. Let's do this. Alternate viewport settings, let's try that. No, it used to say create tree or create branch. Let's see. Now those are just all my drop actions. Node click, no. Pop-up options. Aha. Move branch, create new schematic. It's not what I want. Move branch to new fusion item. Copy branch to new fusion. No, I don't want to do that. I want a new branch. Let's see. Well, that's a bummer. Oops. 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 That's the schematic interface. Okay. Ah. All right. Good luck. Just making a rocket. Just making a rocket with mesh fusion. Okay, let me see if I can figure this out real fast.
Is this model on D2L?
Yeah, so this is all on D2L. So if you look real carefully, it's right there. All these parts and pieces are right on that area. This is going to drive me crazy.
All right, so just one last thing before I go as well. All right, so we have to build this rocket using this fusion thing you just showed us, right?
Mm-hmm.
Okay, and the parts are already in there.
Yep.
And it has, of course, it has to look, just like that one.
Nope, they can look like anything you want.
Really?
Yep, have fun with it.
Using that.
You're just using mesh fusion as a medium for you to create your rocket. I've given you some building blocks.
Okay.
Just make something awesome.
All right.
Yep.
Thank you.
All right?
Pat,
Yeah.
do we even have to use that model? If we wanted to make
If you wanted to make your own rocket ship, I say go for it. Yeah, you don't have to use these pieces. If you want to do your own thing, I say do your own thing.
Is that the actual rocket, or can it be a spaceship in general?
It could be a spaceship in general. Yeah, I'm happy with that. All right, I want to see if I can figure out why I'm not able to make a new tree here. Oh, this is going to drive me absolutely batty. Well, we're not making a new tree. We're making a new branch in the tree. Right. We're only allowed to have one tree. We're trying to make a new branch with inside that tree. And you used to be able, maybe I could all. Let's see here.
So everything's just one fusion item?
Yes, it's all one item. Yeah. Free in 901, yeah. Well, it's actually, I shouldn't say free. It's part of 901 now. It's part of Modo going forward.
If you had 801, you could make the plugin free?
Nope. You have to buy it. Let's see here. What am I missing here? Oops. Don't want schematic. My brain is getting mushy at the end of the day. It's probably right in front of me, and I'm just so tired that I can't see it. well. And it's this new drop action palette that's getting in the way. Yeah, I was just doing that, and that wasn't giving me, I was kind of hoping that would be it, but same thing. So here's me holding down Alt, same thing. Holding down Command, same thing. Okay. Well, let's do this. All else, reference the documentation. Okay. Huh. Is it really not in there? Oh, it can't possibly not be in here. If it's not, I know the first person I'm calling. Wow. So this is the website. Yeah. This is the developer that actually makes Mesh Fusion. This is actually a good website to go through. There's a lot of great tips in here on how to get the best out of Mesh Fusion. So let's go to UI. Yeah, tree branch structure. Yeah, this is what I'm trying to make, a new branch, right? With its own setup, yeah, off of the root. And you used to be able to just take this thing, drag it on top of the root item, you get a popover, it says new branch, and then with union, and then you're on your way. Doesn't even do it. Let's see, or let's make sure it's not doing it before I say that. Okay. Oh yeah. The blue, this is the right now. It just selects all of its children. I really don't know. It's kind of an important idea to be able to make a new branch quickly. Something has changed. That gets rid of all the unnecessary nodes that aren't being used. Let's see if it's under the Fusion item itself. All right, I'm going to have to keep figuring that part out, but there is one more thing in here that I want to show you guys that's actually kind of important. So let's just draw focus to this really, really quickly. Okay, so at the end of the day, the Fusion item is something that's exclusively and only in Modo. Okay, it's a special proprietary item that you will not find anywhere else. So if you desire to use this in some other capacity, you're going to have to convert this Fusion item into something that is independent from the Fusion system. Even then, I think it's still a pretty good idea to convert it anyways, okay? To get a raw mesh item, because there's a lot going on behind the scenes right now on this Fusion item, okay?
You could
Yeah, it's all still live. The scripts that are controlling these live Booleans are still being evaluated. So we want to convert it and get it into a raw mesh item.
Did you save, like, before you convert, you save this scene as is and then have a copy of this so you can come back later if you want to edit it?
Yeah, and they've even done you one more, okay? If you look at the options down here under the output meshes, there's 3. We have duplicate, and convert. So it's going to duplicate the fusion item and then convert it into a mesh item. Or you just duplicate the fusion item, so you have 2 of them, or you can just convert the fusion into a mesh, okay? I'm going to do duplicate and convert. That way I still have my original fusion system and my raw. Oh, and this is saying, hey, it's not airtight final, the mesh mode. Okay. Dupe and convert. It's going to ask you for a name. Let's just call this Death Star Mesh. We're going to duplicate the original. Hit the Create Mesh button. It'll run the script. It's going to think about it for a second. And I think we're good to go now. Yep, there it is, Death Star Mesh. That's the one that's, there it is. See how my fusion item is turned off? Now, this is raw geometry that we can send anywhere. Yeah. Now you can deform it, you can rig it, you can do whatever you want to it. It's just like any other mesh item inside of our system. Yeah. This does not need to be a subdivision surface anymore, okay? What we've done, or what the computer has done, is that it has taken the subdivision level that you were working at, and it's frozen all of the geometry at that level. So if I was to hit the tab key right now, do you see any difference? Very, 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 very little, okay? So you don't need to transform it into a subdivision surface after the fact, okay? Pretty cool. That'd be actually something pretty difficult to model. And I did it within a couple seconds. Now, I got to figure out why that branching system isn't working, because that's going to drive me crazy. All right, let's just revisit what the expectations are for your homework. You're just making a rocket ship this week. Make a spaceship using Mesh Fusion. Have fun. This is supposed to be kind of a fun building block assignment, okay? I want you to explore these tools. They're pretty neat. They're pretty neat. Yeah?
Are we allowed to UV map it?
Please do. Yeah. UV map it. Yeah, go crazy. Question. Yep, who had the question? Yeah, well, here's the cool thing about working with UVs inside of Mesh Fusion. It does do it, okay? It does do it, but the source geometry has to have UVs already done for it, okay? Yeah, if it's already UVs, if your source meshes are UV'd, it will do an okay job of extrapolating all those UVs. Let me show you what I'm talking about. All of these pieces in here are UV'd and ready to rock and roll, okay? So let's use the bottle here, okay? And let's do something fun with it. Get my macaroni piece. And I don't know what I'm doing here. Sure, let's give it a handle. It's a gigantic handle. Oops. Okay, there's no reason Moto should have crashed right then. No reason. Like the only thing I was doing was rotating an item. It doesn't want me to make a handle for my bottle. So the thing that you have to triple check in this process when you're working with UVs, just make sure that your source meshes have UVs before you insert them into the Mesh Fusion system, okay? It has to be before, because if you won't be able to do it after. It's not going to work, okay? In addition, when you're converting, when you're physically at the stage when you need to duplicate and convert, you want to make sure that that Create UVs option is on, otherwise it's not going to work. Let me show you. Go back to my beer bottle. Yeah, have fun. This drives me crazy.
So the source is the one that is getting all the edits and all that stuff too, or is that all
Basically, all the parts have to have their own UVs. Okay.
Those need to be finished before you start doing all that stuff.
Yes. Yeah, you need to have everything UV'd before you do this. Okay. Now, all of these parts are UV'd and ready to rock and roll. I'm just going to do a simple union here.
So if you like want to use your own mesh for the fusion, you want to UV it first.
UV it first, yeah. Okay, there we go. Looking good. Awesome. Coolio. Looking good. Okay, so now if you go over, let's just pretend that we're done with this. Let's do one more. Let's do a subtraction in here too so we can really get a good idea of what this process looks like. Okay. Hole in the bottle. Okay. All right, now just want to make sure that Fusion Mesh UVs is turned on. In the mesh mode, we want to do airtight funnel with parts, so all that stuff gets converted. And now let's duplicate and convert to mesh. Let's call this bottle. Yep, it will even create the material groups for you, which is nice. All right, so here's your bottle. Okay, let's go over to UV edit. There are your UVs. Okay, so it did a pretty good job. There's still some work in here that you need to do, but it did a pretty good job. If everything is...
Those are the UVs for all the parts.
You got it. There we go. Huzzah. It's not bad. It's not bad at all. It really isn't. If you have good UVs, Mesh Fusion will do an okay job. An okay job. I think it does a fantastic job with the presets it comes with. I've had some problems with things that I've made, but they're not insurmountable. They're really not. The other thing that's really neat, and this is actually more important to me than the UVs, is that it creates selection sets for all of this stuff. Okay? So check it out. It's created selection sets for all of the strips. Okay? So if I wanted to go in and just select the strips, I could do that. Okay? So if you don't have good UVs, you can create your UVs quickly by these selection sets. Okay? So I can just create, here's the first bottle, here's the other bottle. Okay, here's, that was the macaroni handle. Okay, here's the cylinder. So just the polygons that were associated with the cylinder. So it's going to make some connections. It's going to remember the polygons that were used in creation of this thing and assign them their own selection sets. It's pretty cool. It's a good system.
And you said it's free with 901, but you have to pay for it.
Yeah, it's like a $400 plugin if you don't have 901. Yep.
All right,
Good luck, guys. You got it.